So first we're gonna do the warm-up. So if you could find those in your packet. They are very easy and quick, which is great news. Okay. All right, so these are called, guys, these are called same base. Please stop talking while I'm talking. These are called same base exponentials. And in both of these, they already have the same base, which is great. So we can cancel out the bases. 2n minus 3 equals 4. Plus 3 plus 3. 2n equals 7. Divide by 2. Divide by 2. N equals 7 over 2. You can make that 3.5 if you want, but I'm going to leave it 7 over 2. Okay, number 10. Cancel out the bases. Negative n equals negative 2n plus 3. Add 2n. N equals 3. Oh, that's a good problem. I like that one. All right. You guys are done with your packet. You can put your packet away. Here is the agenda. We're going to do 5 problems in the notebook. They're all about arithmetic sequences. Let me remind you what arithmetic ones are, the ones that are linear. They're like y equals mx plus b style. And homework is 66 through 71, skip 70, which you already knew, and a bunch of you guys already did. And there's my joke. That's Grumpy Cat. Grumpy Cat is not feeling the holidays. Okay. All right, so number 58. We're going to do 2 things in number 58. We're going to find the equation, and we're going to find out what spot, what number 77 is in. So I'm going to use a different color here. You guys can use a different color if you want. You don't have to. But I'm going to label these things. So I'm going to put little baby numbers underneath to show the term that it's in. So -4 is term 1, -1 is term 2, 2 is term 3. And what I'm interested in is, what is term 77? Okay, first of all, let's just go a little bit slow. What is this arithmetic? Yeah. Yes. It made it. Addition of 3. Beautiful. Okay, so I'm going to go like this. Plus 3. And we call that a common difference of 3. So we're going to say D equals 3. Okay, next thing I'm going to ask you is, what is term 0? What is the y-intercept or the start? Yes, dear. -7. So T0 equals -7. I like to put something indicating that the -7 really isn't part of the problem. It's part of the equation, but it's not part of the number pattern. So I underline it, put an arrow there just to separate it from the actual problem itself. Okay. Now the equation is T of n equals 3n minus 7. Anybody want to talk about the equation at all? So this is your y equals mx plus b, but we're just writing it in sequence notation. Okay, now what we're going to do is figure out what spot 77 is. And so we're going to ask ourselves, T of what spot is 77? So we're saying, what is n if for the number to be 77? So what I'm going to do is I'm going to take the 77 and plug it in the T of n spot right there. So I have 77 equals 3n minus 7 plus 7 Try not to have anxiety about how much my calculator is going to die. It is nice. Did you do that in your head? Okay, so we're going to write this in a couple of ways. We're going to say 77 is the 28th term. So 77 is in spot 28. And we're also going to write it like this. T 28 equals 77. So this is saying term 28 is 77. Okay, one done. 4 to go. Number 60. I need the book for this one. Seven years ago, Cody found a box of old baseball cards in the garage. Since then, he has added a consistent number of cards to the collection each year. He had 52 cards in the collection after 3 years and now has 108 cards. How many cards were in the original box? Blah, 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 blah. Okay, so we need a couple things. We need 7 years ago. He started the box of, or found the box in the garage. He had 52 cards after 3 years and now has 108 cards. Okay, so I'm going to label my table with years and cards, and I always make a spot for zeros. So this is when he found the box in the garage. And then it said 3 years later, he had 52 cards. And now, which is 7 years later, because he found the box 7 years ago, he has 108 cards. Any questions about my setup here? Okay, what I'm going to do is treat this like a problem from chapter 2. I'm going to find the slope and the y-intercept. So I'm going to go over here and write 352, 7, 108 m equals y2 minus y1 over x2 minus x1. One oh eight minus 52 is 56. 7 minus 3 is 4 equals 14. Okay, what does this 14 represent in the context of this problem here? Yes, Landon? It is, but what is it for this particular problem, Dylan?
Right.
It is, but what is it for this particular problem? Yeah, how many? What? No. Yeah, the amount of cards added each year. Okay, so now we're gonna say x equals y equals, and I'm just gonna pick this first point because I'm lazy and it has lower numbers. Okay, what does the 10 represent in the context of the problem? Yes? Yep, beautiful. Okay, now this is very important. Please note this next step. I know you guys could all do this. Like I could put this up here and you guys could all do this part. But we're in the sequences chapter. Would you all agree with me that the function has the equation y equals 14x plus 10? So 14 is the slope, 10 is the y-intercept. Now we're in the sequences chapter, so we have to change this to be sequence notation. So t of n equals 14n plus 10. These two things are different, very similar, but different in meaning this is a line where you draw the line through it. This is a number pattern where it's just the numbers associated with this pattern. So final answer is this because this is a sequence. Two down, three to go. Sixty-one. Trixie now wants an arithmetic sequence with a common difference of -17 and a 16th term of 93. Is it possible to create an arithmetic sequence to fit her information? If it is possible, write the equation. If it's not possible, explain why not. Okay, common difference. What is the letter we use for that? D, right, D, difference of -17. So everybody on your paper write D equals -17. And then right below that, write this. Okay. This is the slope. This is your x. And this is your y. difference is the slope. This is term 16, which is the 16th number, and the 16th number is 93. Okay, so come down here. Can you see where this is going? Okay, 93 equals negative 17 times 16 plus b. I don't even know what 17 times 16 is, though. Number of days in a year? Who knew? Correct myself up. Okay, y equals negative 17x plus 365. Okay, however, we're in sequence notation. How do I switch this to sequence notation? Is it really just not that fun and interesting? I need to get Honor into a class where he likes what's happening. He's always so unhappy. Mhm. 3 down, 2 to go. That's not the problem. Okay, 64. But we're just going to do A. Write an equation for each arithmetic sequence represented by the tables below. Okay, now can you guys don't do the whole thing. Just write this little bit of this table. So n, t of n, and just do the 3, 7, and 3, 54, and 10. There you go. Okay, this is what I want you to do. I want you to find the slope. I want you to find b. I want you to write the equation, and then I want you to change it to sequence notation. Do it in a group. You can write them as coordinates if that helps your brain. So 7 comma 54, 3 comma 10. Solve it like it's a slope. It is a slope. Well, that's not actually the proper sentence, but you know, it's fun. Okay, so I got my slope is 11. My y-intercept is negative 23. And then ask me what was, okay. And then final answer, T of n equals 11 and minus 23. Okay, one more problem. 65, and that's it. Okay, okay, so what we're going to do in 65 is we're just going to talk about the difference between a function and a sequence. Okay, for a function, it's the ones we did today are called linear, and the sequence is called arithmetic. The equation is y equals mx plus b, or f of x equals mx plus b. And those two are the same thing. The equation for a sequence is T of n equals dn plus T0. But I'm really hoping that you can see the y equals mx plus b living there. It's just different notation because it's a sequence. A function has infinite coordinates. A sequence are only the numbers in the pattern. However, they both make a line The line for the function has arrows on both ends and is connected, and that's called continuous. And the sequence just has the dots that are for that number pattern, and that's called discrete. Okay. If you have not, then I'd like you to have a few minutes to work on that. If you have, you can chill.